All right, 9.1, we're looking at determining probabilities. We talked about what that means a little bit. We've done some examples. And we are to my very last example, which is back to the data that we had seen at the end of Chapter 7. So recall, as of August 1st, 2020, the total number of positive cases of COVID-19 in the state of Oklahoma stood at 37,731. The population as of July 1st, because that's the closest I could get, remember, was 3,956,971. So we're going to ask part A. On August 1st, what is the probability of interacting with someone who had tested positive for COVID-19? Now, please keep in mind and remember how that disease worked. That doesn't mean they were currently sick, right? They were supposed to be at home if they were currently sick. That's not the people we're talking about. We're just talking about the fact that, hey, you're having a casual conversation. The person you're talking to happened to have had it in the past, 8 months, basically, since people had started, reporting it. Okay, so we're going to take a look at what the probability is. Well, probability was always calculated as the number of items in our event, A, divided the number of items in our sample space. So our event in this case is that somebody you're talking to, that person is somebody who had COVID-19. And that here is the number 37,731. And then our number in our sample space is our population, the number of people that we were talking about that lived at that point in the state of Oklahoma. So that's 3,956,971. And we can divide these. And in fact, we're going to be working some more with some division where we report things back in terms of decimals. So go ahead and grab your calculator and let's report this, because I know what the number is going to be, to 4 decimals, because that's a convenient place for us to stop. So let's write down 4 decimals worth for our answer here. Okay, what do we get? It's very small. What'd you get?
0.0095.
Yes, ma'am. Thank you so much, Callie. 0.0095. Okay? And remember, in terms of decimal names, this right here has a place value. It's the 10,000th place. So what this is actually meaning is that it's 95 in every 10,000 people, to give you some sort of perspective. It's almost 1 in 1,000. Okay, so this is less than 1%, right? Less than 1%. 95 in 100,000, and I think I just said 1 in 1,000. I meant 1 in 100. So this is approximately 1 in 100. So less than 1% that this person that you talked to had it. And so I don't know if you remember sort of where you were in that time frame, but I do remember having conversations with people at our church going, do you even know anybody, like really, really know anybody who's a super close person to you who's had it? And most of us at that point didn't. 1 in 100 is not very many people who would have known somebody like personally, not just like, my friend's cousin's neighbor. We all knew people like that, but like somebody you actually knew in your circle who'd had it. And so it was still very, very low by the time that we were at August. All right, let's take a look at one more of these. Also, on August 1st, it had been reported that there had been 549 deaths in the state of Oklahoma, and there were 30,280 people who had recovered. Okay, so remember, it said, I'm going to put this number on the screen, that there was 37,700, 731 who had tested positive. And there were 2 outcomes, right? You either made it through on the other side of recovery or you passed away. I mean, that was the result, right? Those are the 2 outcomes. And the third possibility is that you're still sick with it. Like you just got it really recently, and so you aren't quite the recovered part of it, but you're still alive. Right? There's really kind of 3 possibilities of those 37,000 people at that point. So the question then asks if we're back to August 1st, what's the probability that you're actually talking with someone who has it? Not just that you knew somebody who had gotten it at some point in the past 8 months, but you're actually talking with somebody in real time who actually has it. So we're going to find the same thing here. Okay, we still have our 3 million number on bottom, 3,956,000. 971, sorry. But now it's not 37,000 people on top. It's supposed to be the people who are still currently sick. Okay? So 37,731 tested positive. 549 of them passed away. And 30,282 recovered. Does everyone understand why I'm subtracting the pieces and where they're coming from? Okay, that's good. What do you get when you subtract everything on top? Let's just get that number first. It is 6,900. So on that given day, right then, reportedly, there would be 6,900 people who were still sick, or maybe they hadn't reported what had happened to them yet. Maybe the person had passed away, or maybe that person had recovered, but it hadn't been reported back to the government that they was keeping track of these things. So if you take this and divide that, go ahead and give that one a go. Okay, 0017. So again, for some perspective, this is 17 in 10,000 people. Or you could say that it's approximately, right, if we round 2 in 1,000. Right, 17 is almost like 20, 2 in 1,000 people. 2 out of every 1,000 people that you would talk to. And since most people were still hanging out in their house, they probably weren't talking to very many people at that point. But 2 out of every 1,000 people that you talk to approximately would be sick on average.
So is that holding our answer?
The answer is this part right here. I'm trying to give you some perspective of what it means in the context of the problem. Sometimes it's really easy for us to take answers and to not know really what we found, like what relevance it has. And so this is my attempt at taking a concrete situation that you are familiar with. I know you guys are fairly young still because you're just freshmen and sophomore, most of you in college, right? Freshmen and sophomores mostly. So you were talking freshman and sophomore in high school. So these were things that were in your high school experience, actually. And so I wanted to use an example that was relevant. So, yeah.